Hello, my wonderful viewers. You're welcome once again to Frequency Online Maths. One of us brought this question for me to solve, so I decided to make a video on it so that others will learn from it. Using definite integral approach, show that the area of a circle is what? Pi r square. So we write our what? Solution. We all know that area of a circle is equals to pi r square. But they are telling us to use what? Definite integral approach to show that the area of a circle is what? Pi r square. So we are going to draw a circle. We draw our Cartesian plane, the y, we draw our Cartesian plane, the y axis and the x axis. So this place is x axis, y axis, negative y, negative x. So this place is my point of what? Origin. That's O. Supposing Suppose I draw a line from here to any part to this circumference. What is it? It is what? A radius. So the radius is a line drawn from the center of the what? Circle to any point on the what? Circumference. So from this place to this place is also what? Radius. If I draw a line perpendicular to this x-axis, I have formed what? A right angle. Let me call this place theta. So I can call here y and x. Remember that this whole place with this circumference is what? R, which is what? Radius. If I draw another line from this place to this place, is also what? Radius. So remember, this place is what? First quadrant, second quadrant, second quadrant, third quadrant, and what? Fourth quadrant. So this the area of this whole shape, this whole circle, I can just find the area of this sector, this first sector, and multiply it by 4. I will find the area of the what? Whole circle. So I'm going to say that using Pythagoras theory, using Pythagoras theory. Pythagoras is telling us that the sum of the and that this hypotenuse is equal to the sum of two other side, which is the adjacent and the what? Opposite. So that our r squared is equal to x squared plus y squared. I have obtained what? Equation of what? A circle. Equation of a circle. So I want to subtract what? X from both sides. So my y will be what? Y squared is equals to r squared minus x squared. So if I square both sides, it will be y is equals to square root of plus or minus r squared minus x squared. That means when I square what? Both sides. So because this y-axis in the first quadrant is what? Positive, and the x-axis in the first quadrant is what? Positive. Everything in this first quadrant is what? Positive. Both sine, cos, and what? Tan. All of them are what? Positive. So I'm going to use y is equals to positive square root of r squared minus x squared. So this is what I'm going to use. So my area is going to be what? The integral from 0 to what? R. 0 to, you know that this line is what? Radius, R. The integral from 0 to what? R of the function square root of r squared minus x squared dx. So that will be my integral. So remember I told you that if I find this area, this sector, that I will multiply it by what? 4 and find the whole what sector, because it's what? 4 quadrants. So I can put what here? 4. So I will have what? My area like this. So we are going to use what? Let me clean. Okay, let me clean this side. Okay, let me stay easier. We are going to use using SOHCAHTOA. We know that cos theta is equals to what? Adjacent all over hypotenuse. So cos theta is equals to, what is the adjacent? X all over hypotenuse is what? R. So that r cos theta is equals to what? X. Therefore, our x is equals to r cos theta. So we are going to find the derivative of what? This x is equals to r cos theta. It's going to be what? The x is equals to, we keep this one, this r constant. R, the derivative of cos is what? Sine is what? Minus sine. Minus sine theta d theta. So if you go to my previous video, I made a video on how to find the derivative of what? Three functions. The derivative of cos theta, tan theta, cot theta, sec theta, all these derivative of three functions. I did the video on it. So I made a video on it. So we are going to have, let's bring this area. Area is equals to the integral from 0 to r of the square root of r squared minus, remember our x is r cos theta, so they say x squared, so it's going to be what? R squared cos squared theta. Then the x is now what? R minus sine theta d theta. So that's our what? Our r. So area is equals to, okay, we can do something here. We can factor this minus. So it's going to be what? Minus 4 integral from 0 to r of the function r squared minus r cos squared theta. Then r sine theta d theta. So are you seeing something now? We have factored out what? This minus. So let's proceed. We are going to find another thing from what? This SOHCAHTOA. Remember that we are now dealing with what? With respect to what? The theta. Before we are dealing with respect to what? The x. And our limit is from 0 to r. Now we are now dealing with what? The theta. So our limit will also what? Change. So we are going to recall from SOHCAHTOA again that cos theta is equals to x over r. So this one will be our x now. So we are going to, anywhere we see x, we put what? 0. Cos theta is equals to what? 0 over r. So that cos theta is equals to 0 over r is what? 0. So cos what will give us 0? Cos 90 degrees is equals to what? 0. So, or you say, you convert it to what? In radial form, it will be what? Pi all over 2 is equals to what? 0. Pi all over 2 is the same thing as what? 90 degrees. So, we are going to do it again in this place. You know that we are looking for our what? Our limit. So, cos theta is equals to x over r. Then cos theta is equals to, we are going to use this upper one now to replace this x. So anywhere we see x, we put what? R over r. So cos theta is equals to r by r is what? 1. So cos what will give us 1? Cos 0 is equals to what? 1. So our limit is now what? 0. So we are going to rewrite it here. Let me clean this side. We are going to rewrite it. So our area now is equals to minus 4 integral from, it will now be from pi over 2 to what? 0. Because it replaces what? 0 to what? R. Then square root of the integral of square root of r squared minus r squared cos squared theta, then times r sine theta d theta. So we are going to have area is equals to, we can remove this minus 4 by what? Flipping the what? The limits. So it's going to be 4 integral from 0. This 0 will come down. This pi over 2 will go up. Pi over 2, so that the minus will go. Square root of x squared. I said x squared. Square root of r squared minus r squared cos squared theta. Then multiply r sine theta d theta. So we are going to factorize. Our area is equals to the integral from 0 to pi over 2 square root of, we can factorize r squared is what? Common. R squared minus r squared, then bracket 1 minus cos squared theta, bracket close, times r sine theta d theta. So what are we going to do again? We are going to write area is equals to the limit from 0 to pi over 2, the function of r squared. Now let me write important 3 identity here. Let me drive it this side. Okay, should I drive it here? Will it confuse you? Let me drive it here. We have 3 identity that says sine squared theta plus cos squared theta is equals to 1, and sine squared theta is equals to 1 minus cos squared theta, and cos squared theta is equals to 1 minus sine squared theta. So we have another double angle identity which is telling us that if you have cos 2 theta, that is equals to what? Cos squared theta minus sine squared theta. So it's going to give you what? That cos 2 theta is equals to, cos squared theta is what? 1 minus sine squared theta minus sine squared theta. So cos 2 theta is equals to 1 minus sine squared theta minus sine squared theta is what? Minus 2 sine squared theta. So cos 2 theta is equals to what? 1 minus 2 sine squared theta. So this one will come over this side. This one will go to the other side. So we are going to have positive 2 sine squared theta. That's if this one come over this side. This one will come over the other side. So we are going to have 1 minus cos 2 theta. So when we divide both sides by 2 to make sine squared theta subject of the formula, we are going to have sine squared theta is equals to 1 minus cos 2 theta all over 2. So these are the important identities we are going to prove to help us solve this effectively. So we are going to have 1 minus cos squared theta is what? 1 minus cos squared theta is sin squared theta. So we are going to replace this with sin squared theta. Then times r sin theta d theta. So let's move over to this side. So we are going to have that our area is equals to the integral from 0 to pi over 2 square root of, remember that this thing can be written as square root of r times square root of sin squared theta, so that this one will cancel. We are going to have, or you can say square root of r is what? Square root of r squared is what? R. Square root of sin squared theta is what? Sin theta. Then times r sin theta d theta. Anyone. So we are going to have area is equals to 4 integral from 0 to 5 over 2. This times this is what? R times r is what? R squared. Sin theta times sin theta is what? Sin squared theta d theta. So we are moving somewhere, we are heading to somewhere. So we are going to have area is equals to, we are going to keep this r squared what? Constant. So we are going to have 4 times r squared integral 4 times r squared integral from 0 to pi all over 2. Are you seeing it? Now, times, sorry, the integral of what? Sine squared theta d theta. So we are going to have area is equals to 4r squared integral from 0 to pi all over 2. Sin squared theta is what? According to the double compound identity. Sin squared theta is what? 1 minus cos 2 theta all over 2 a theta. So we are going to keep these two constants again. So we are going to have area is equals to 4r squared divided by 2 integral from 0 to pi all over 2 bracket 1 minus cos 2 theta all over 2 d theta. So we are heading to somewhere. 2 here, 1, 2 here, 2, 2 here. No, sorry. Okay, yes. We multiply both sides by what? So these two will go. So we are going to have area is equals to 2r squared integral from 0 to pi all over 2, then bracket 1 minus cos 2 theta d theta. So this is what we are going to do what? So 1 minus 2 cos 2 theta 1 minus 2 cos 2 theta d theta. Okay, let me clean this side. So we are going to have we are going to have we are going to have area is equal to 2r squared from 0 to pi all over 2. Let me write this thing here so that you see it. 1 minus cos 2 theta d theta. So let's integrate directly. So our area is equal to 2r squared. Then the integral of 1 is what? This is a constant. With respect to what? Theta is equal to what? Theta. So minus the integral of cos is what? Sine. This thing is cos 2 theta. So the integral of cos 2 theta is equal to what? Sine 2 theta. Remember, this thing is what? A function of what? A function. Function inside what? Another function. So we are going to apply what? Chain rule. So we integrate this cos, it gave us what? Sine. So we are going to differentiate this 2 theta now. It's going to give us what? 2. So we are going to divide it by the what? Derivative over 2. So bracket close. We are going to write our boundary, that's limit from 0 to pi all over 2. So we are going to have area is equal to 2r squared bracket. Anywhere we see theta, we put what? Pi over 2. So we are going to have pi all over 2 minus sine bracket 2 times pi all over 2 all over 2 minus, anywhere we see theta we put what? 0. 0 minus sine bracket 2 times 0 all over 2. So we are going to have area is equal to 2r squared bracket pi all over 2 minus, this one we cancel, sine pi all over 2 minus 2 times 0 is what? 0. Sine 0 is what? 0. 0 divided by 2 is what? 0. 0 minus 0 is what? 0. So minus 0. So we are going to have area is equal to 2 pi r times pi all over 2. Because sine pi is what? Sine 180 degrees is what? 0. So 0 divided by 2 is what? 0. So this one is out. So we are going to cancel this one, so that our area is equals to r squared times pi. Therefore, our area is equals to pi r squared. Proved. Or I can write it here. Our area is equals to pi r squared. Proved. So thank you for watching and may God bless you. Please don't forget to subscribe on our YouTube channel. Follow us on our Facebook page, Instagram, TikTok, and the rest. Bye bye.